This video is for Chemistry in the Earth System, Unit 1.5, Tectonic Plate Interactions. Today's essential question: what are the three types of plate boundaries? Our first main idea: convergent boundary. A convergent boundary forms when two plates move together. This type of boundary forms between two oceanic plates, two continental plates, or an oceanic and a continental plate. Features along a convergent boundary result from the compressional forces. When an oceanic plate converges with a continental plate, the oceanic plate sinks below the continental plate. Oceanic plates are made from mainly basaltic rocks. They are more dense than continental plates that are made mainly of felsic or granitic. Oceanic plates form at mid-ocean ridges and may be destroyed when they meet each other. This convergence produces a feature called a subduction zone, which forms when an oceanic plate meets and then goes beneath a less dense continental plate. A convergence zone also forms when two oceanic plates collide. One plate passes beneath the other. The convergence of two continental plates produces a mountain building event. During the event, rocks and sediment are thrust together, tilting and deforming rock layers and causing wide-scale metamorphism. Geologists study the location and depth of earthquakes along subduction zones to understand how converging plates behave and deform. A case study in convergence: the Himalayas. The Indian subcontinent has been on the move for 71 million years. Beginning 10 million years ago, the Indian plate collided with the Eurasian plate, producing the Himalayan mountains and the Tibetan plateau. The event affected an area larger than 2,400 square kilometers. Mount Everest, part of the Himalayan mountain chain, towers 8,848 meters above sea level. The region is still experiencing uplift as the Indian plate continues to collide with the Eurasian plate. The western region of the Himalayan mountain chain, called Nanga Parbat, is currently experiencing the highest rate of uplift, approximately 1 centimeter per year. Scientists think that over the next 5 to 10 million years, the continued collision will force India another 180 kilometers farther inland. Divergent boundary. A divergent boundary forms when two oceanic plates or two continental plates move apart. Divergence does not occur between an oceanic plate and a continental plate. Features along divergent boundaries result from tension and extensional forces. A spreading center marks the divergent boundary between two oceanic plates. A triple junction in the shape of a Y marks divergence of three continental plates. Each arm of the Y becomes a long rift or crack in Earth's crust. Two such rifts separate Africa and Arabia, forming the Gulf of Aden and the Red Sea. The stem of the Y forms the Great African Rift Valley, which is ripping the interior of East Africa apart. This valley is characterized by volcanic activity and deep lakes. As the rift opens wider, it will deepen further until the surrounding ocean floods in, creating a new gulf or sea. A case study in divergence: the Mid-Atlantic Ridge. A mid-ocean ridge system consists of a series of volcanoes and fissures that form along a spreading center at a divergent boundary. During seafloor spreading, the plates move apart. The heat from the magma makes the surrounding lithosphere less dense. As a result, the lithosphere rides higher on the asthenosphere, accentuating the height of the mid-ocean ridge system. Magma wells up from Earth's interior and rises to the surface through volcanoes and fissures, forming new oceanic crust. The crust slowly moves away from the fissures in two opposing directions, eventually creating new ocean floor. Beginning in the northern Atlantic basin, the mid Atlantic ridge bisects the length of the Atlantic basin. But as the mid Atlantic ridge curves around the southern margins of Africa and South America, it enters the Indian Ocean from the east and the west. Transform boundary. A transform boundary forms when two plates slide past one another parallel to the plate boundary. Transform boundaries can occur under the ocean or on land. At a transform boundary, crust is neither made nor destroyed. Instead, the plates push against each other, producing enormous stress that builds up potential energy. When the stress reaches a critical threshold, potential energy suddenly transforms into kinetic energy, and the plates slide parallel to each other. Transform boundary case study: the San Andreas Fault. Along the coast of California, the Pacific Plate and the North American Plate are in direct contact. The two plates moved laterally past one another, parallel to the transform fault. This transform boundary in Southern California is called the San Andreas Fault. The fault is about 1,300 kilometers long and spans the southwest section of California in the United States. The city of Los Angeles is located on the Pacific Plate. Sacramento sits on the North American Plate, and San Francisco sits near the San Andreas Fault where the two plates meet. The Pacific Plate is slowly migrating north along the fault. At some point in the distant future, the cities of Los Angeles and San Francisco will likely be neighbors. At this point, you should be able to generate a full and appropriate response to today's essential question: what are the three types of plate boundaries?